In this video, we're going to review the concepts of observation and inferences. So science is a process. It's not just a collection of facts. It's the way that we gather information about the world to learn about the world. And those facts that we know about science, they're not just made up. Science is based on evidence that we've collected about the world through experimentation. And the way we collect that evidence can be through inferencing and or observations. And so today we're going to take a look at what inferencing means and also what observations are. Let's start with observations. Observations is when you collect information about the world using your five senses. So, for example, your sight, smell, touch, taste, hearing. And observations can be of two types. They can be quantitative observations and qualitative observations. Quantitative, think quantity. That's when you describe something using numbers. So there's a measurement involved. There's a numerical value involved. Qualitative observations, think quality. That's when you describe using descriptive words like the color, texture, or smell of something. So if we look over here, if we say there's 1, 2, 3, 4, 5 marbles, that's a number. That's a quantitative observation. If you were to measure their diameter to say it's 1.5 centimeters, that's a quantitative observation. If you were to say that these are smooth and that they're beautiful, that would be more of a qualitative observations because you're using descriptive words to describe those marbles. Here we can see that there's 13 trees. That's a number, so quantitative observation. Here we can see there's blue, red, and yellow birds. Those aren't numbers, those are descriptive words, colors, so that's a qualitative observation. But if we were to count the number of birds and tell you how many birds are there, then you would say it's quantitative. And over here, if we were to say the trees are green, then that would be qualitative. In science, when you make observation tables, you're making observations and you're collecting information about substances. And so oftentimes you're looking at their properties, like their physical properties. So those physical properties that you write down in your observation tables are you taking observations, and they can be qualitative or quantitative as well. So we can have qualitative physical properties which describe a substance's physical properties with more descriptive words. They don't necessarily have a numerical value with them. So, for example, it could be things like color, odor, texture, the state of something, clarity, the luster, taste, if something's ductile or malleable or brittle. So, if we look over here at this picture, we're measuring some sulfur on a balance, and we could describe it with qualitative physical properties. For example, it's yellow, it's a solid. But then you can also describe a substance using quantitative physical properties with numbers, with measurements. So you may have seen a thermometer and measured temperature before, or you may have used a ruler to measure the height of a plant, or you may have used a balance to measure the mass of a substance that you're dealing with in the lab. Solubility, we'll learn later, is also based on a number. Density, you've done through calculations. The boiling point, melting point, and freezing point, those are all quantitative physical properties. If it's reported as a number, so is conductivity. Viscosity, using a viscometer, is also a quantitative physical property. Hardness as well, because it's actually based on a scale that gives you a number that tells you how hard something is compared to something else. So a higher number is harder than a lower number on that scale. So if it's presented with a number, you're dealing with a quantitative physical property. Those are observations. Now we'll take a look at inferences. So inferences, it's not something that you've directly seen, you've directly tasted, you've directly touched. It's more your interpretation of the observations that you made. So it's an explanation or interpretation of the observations you made. Let's take a look at a science example. Here we have the atom. And as you know, we can't see the atom. Scientists had to do experiments to figure out what the atom looked like to make a model of it. And again, they could not see it. So what some scientists did is they took some positive particles and shot it towards some materials, and those positive particles would, some of them would deflect, have these large deflections. So the observation was basically that when we shoot these positive particles at these materials, there's some large deflection. Not a lot, but there's some large deflections, more than we would anticipate normally. And so what scientists inferred from that is that since the positive particles are being deflected, there must be some positive charge in the atom, and that positive charge is concentrated in somewhere in the center. It's concentrated. And so the reason they inferred that is because, again, it wasn't a lot of deflection happening. It wasn't many of the particles being deflected, but those that there were some large deflections. So what they basically, again, inferred from that there's positive particles in a nucleus that's very, very concentrated, and that the rest of the atom is essentially empty space. So they didn't directly see that stuff, but based on their observations of deflection, they could infer that. And so in science, we use observations and we also use inferences to come up with these models and to make conclusions and to understand the world more effectively. So here you can practice on making some observations. For example, I could say there's one person here. So one person, that could be a quantitative observation. There's a broken branch. So I could say it's a qualitative observation. There's one goat. There's one, two, three rocks. So those are all examples of observations. You're just essentially telling me exactly what you see. You're not trying to come up with any conclusions or infer anything. That's basically it. You could say, for example, that the individual is frowning, right? They have a frown on. Then you could also make inferences. And so I want you to be careful here. When you say this individual is frowning, that's an observation, right? They're making that face, that frowny face. An inference from that could be they're sad. So this is the observation. But an inference would be, for example, sad or mad. We don't know if this person is actually sad or mad. We're inferring that based on the face that we're observing. Okay. So that would be an example of an inference. Some students might infer that the branch was broken because the person climbed on it, and that's why the person is now in the pond. Or some students may infer that the goat kicked the person into the pond. So those are all examples of inferences. They're not things that you've necessarily observed directly, but they're explanations of your observations. So you can try these examples out. You can pause the video and just label these as either observations or inferences. So here we have Linus is looking at a puddle of water. And so here we have Linus, and Linus is looking down at the ground. Yes, we know that, but we don't know if this is water necessarily. We don't know if Linus is looking directly at that. We can infer that, so that's more of an inference. Linus is thinking as he studies the puddle. Again, that's more of an inference as well. So this part, Linus stomps on the puddle. So we're seeing that Linus is stomping on the puddle. That works. Linus is angry when he stomps on the puddle. That's more of an inference. We're just looking at, if someone's stomping, it could be an indication that they're angry, but that's more of an inference than anything else, because we're not really observing them that they're angry. We're just observing that they're stomping. Linus produced more than 5 little puddles by stomping on the big puddle. So if you look over here, there's more than 5 puddles that are there. So that there is an actual observation. None of the puddles produced are as large as the original puddle. And that's also true. Here's the original one, and here's all the smaller ones, and so none of them are as large as that. So that would be an observation as well. If all the small puddles got combined, it would be the size of the original puddle. That's what you would think. Now, we actually haven't done it yet. It should be, but that's more of an inference, because we didn't really observe that yet. We don't know if all of these puddles here are include the main liquid from the original puddle. We don't know that. So that's more of an inference that we're making. Linus is smiling as he leaves the puddle. Yep, that's true. Linus is smiling. That's an observation. Linus is happy. We don't know that. That's an inference. He could be mad still. There's a lot of people who put on a smiley face when they're mad, pretending to be happy. So we don't know that. So that would be an inference. Linus is a friend named Charlie Brown. Well, this here, I suppose it depends. If you read a lot of Charlie Brown comics, you could say it's an observation. In this case, we don't see Linus with Charlie Brown, so we're going to say it's an inference because we're just inferring this is the Linus from the Charlie Brown comics, even though it's all over the place. So here we have some practice examples about observations and inferences. So you have to classify these as either observations or inferences, and if they are observations, you need to classify them as quantitative or qualitative. And so you can quickly pause the video and try it out, and then you can take a look at what the answers are. Carbon dioxide is given off by a burning candle. And so we're not directly seeing the carbon dioxide, so that should be an inference. The candle is 10 centimeters long, so assuming you measured the candle, that would be an observation and a quantitative observation. The candle has a diameter of 2.5 centimeters, so if you measured that, then that would also be a quantitative observation. A candle flame shows three different colors, so if you're looking at it, then that would be a quantitative observation as well. Now, if I had described those colors, if I had said, there's orange, yellow, so on and so forth, then I would have said a qualitative observation. The black smoke coming from the candle is carbon. So we don't know that that's actually carbon. I mean, we do from experiments, and scientists do know that. But when you're looking at a candle, you can't really write that in your observation table because that would be more of an inference. So you're making an inference that that's carbon. You're not actually seeing the carbon atoms. If oxygen is removed from around the candle, the flame is extinguished. There again is an inference. I mean, we know it's going to happen from past experience, but we're not directly observing that right now. So we're going to infer that will happen. The length of the candle changes slowly as it burns. If we're observing that, then that's true, and we're doing a qualitative observation there. Just the way we describe it is qualitative. If we actually measured the length over time, then it's going to be quantitative. I gave you numbers for it. The wick extends from the top to the bottom of the candle. So here's the wick, and what we're basically saying is that it goes all the way from the top all the way down to the other end. And we're not directly seeing that right now either. We'd have to cut it open to take a look if that was true. So right now we're just inferring. The burning candle makes no sound, so we're using our hearing, and that would be an observation. It would be a qualitative observation because there's no number associated with it. Carbon causes a yellow color in a candle flame. So if you were just to say that there's a yellow color in the candle flame, that would have been a qualitative observation. The inference in this statement is that carbon is causing it. We're inferring that that's carbon doing that, but we haven't directly observed that. The candle flame will burn if you put your hand, will burn you if you put your hand in it. So if you actually did touch it and you said, ouch, it burned me, then that would be an observation. Right now we're just inferring that candle flame will burn you. And then the candle flame emits heat and light. If you're looking at it, you can see light. If your hand is near it, you can feel the heat. So that would be a qualitative observation.